Alright, just gonna create a null for here and it's gonna be output underwater, just so that there's no confusion. And we're gonna keep working on that other branch, and we're gonna close this surface and turn it into a volume. To do so, let's extract the edges, and we want the unshared edges. So there is a little problem. We need to clean some stuff, like some primitive were a bit crazy, so that should get rid of them, but at the same time it's creating some holes inside the geometry. So let's first call that border, and we're gonna create a polyfill to try and fill the gaps. Let's switch that to triangle fan, that might be a bit faster. And well, as you can see, there is some pretty crazy things going on. So to fix this problem, we're gonna create a measure node and measure all the primitives. We're gonna measure the perimeter of each primitive, and it's gonna export that as an attribute called perimeter. And now if we drop a delete node, let's change that to delete by expression, and we're gonna enter at perimeter greater than 100. So that should get rid of the largest face, and at the same time it's closing the holes that we needed. So as you can see, we got this perimeter. Most of the values are between 1 and 10. So if you set 100, it's basically like you were sure to get rid of the large face. If I set to 50, we can see some holes appearing again. So no, let's set that to maybe 120 to be safe. So from here, let's create a group promote. We're gonna convert this edge group into a primitive group, like so that we can just isolate those faces really. And I wanna still keep the original group of edges that we have, and this new group will be called border geo. So now we can blast the border geo group and delete non-selected, and we got all the faces that constitute the border of the geometry. So from here, let's poly extrude, and the group we wanna poly extrude will be the border, so the edge group. Let's do a transform extrude front and scale that to 0, and we're gonna add a little offset in Y's to make some room. And inside the poly extrude, let's export the extrude front seam so that we can actually use another poly extrude and call this poly extrude seam, extrude front seam, sorry. Let's transform it. Let's set the scale Z to 0. And let's move this group in the end. Just trying to find a place where we are hiding all those faces and it looks kind of closed, like so. Yeah, I think in that case that would be acceptable. Now we're gonna merge this geometry with the original geometry that we had. So this is actually an optimized way. It's not necessarily super clean, but it's optimized. At least it's not crashing. So let's group all this node into a subnetwork, and we're gonna call this subnetwork closed geometry. Let's edit some things. We're gonna expose some parameters. So let's dive inside, and we want to expose not that one. Yeah, probably the poly extrude. So that would be the translate and probably the scale as well. In here, I think that's all right. Let's click OK. So from there, you probably wonder, this guy is crazy. We should have done that just with a basic poly extrude. I mean, if you can, yeah, sure, you can do that. But if your terrain is millions of polygons, the poly extrude might crash. So that was a way to turn around that and try to just keep the bare minimum of polygon to close the model. All right, from here, we're gonna remesh this guy. So let's drop a VDB from polygons like that. And let's see. So the default value might be a bit too low. So let's increase, let's say 5. So 1, you see that it doesn't quite manage to figure out the volume, but 3 in this case seems acceptable. Let's convert that back into a polygon. with the convert VDB. And now we have a proper mesh. That's pretty neat. You probably noticed that we are losing some details, and we can't actually decrease the voxel size. So what we can do is just reconvert that back into a VDB. But this time, if we change the voxel size to 2, that would work because we just closed the mesh properly. And now it managed to figure out some decent voxel. So let's convert that back into polygon. And yeah, we have a denser mesh now. Can even like lower the voxel size to 1 and still works. So we're gonna reproject the detail that we had. So let's use array node and plug the second input back to the original mesh, and let's change the method to minimum distance. Should take a bit of time to update, but eventually we got the points reprojected, and it looks very similar to what we had before, except that it's closed. It's a closed volume, so that's great. And we got a decent amount of polygons to play with and add extra detail. So we're gonna create a backdrop for that and probably apply a color on this one. And actually, I'm going to create another control inside this subnetwork. As you can see, we closed the geometry with some polyextrude, but we could also, at this point, use a polyfill. And the polyfill, we would need to specify a boundary, which would be the extrude front seam. And let's change the fill method to triangle fan to optimize a bit. So why didn't we do that? It's because in some situation, polyfill might get some weird result. So, well, it's at your convenience. I'm giving those two options. Feel free to use whatever should work better in your situation. So I'm gonna create another control inside this subnetwork, and we're gonna call that switch polyfill, like switch to polyfill. All right. Let's copy this parameter, and we're gonna pass that as relative reference inside this switch. So now we can actually swap from polyfill to extrude. Pretty handy little tool. So even with the polyfill, still managed to figure out the volume. That's great. And let's see how it looks with the underwater. So as you can see, we still get a pretty decent transition between the cliff and the ground. Let's just clean the degenerative primitive of the underwater ground. And yeah, it's matching pretty well. We can now move on to the next part.